So, welcome to everyone. So, in this lecture series, we are seeing the electrochemical sensor and what are the major influence in the fabrication of electrochemical sensor and how to improve the sensing behavior or sensing characteristic using nanomaterial. So, in this lecture series, next we are going to see the in the previous uh, lesson we discussed about the importance of electrochemical sensor and what are the constituents playing important role and how the nanomaterial will uh, play a impact on improving the sensing characteristic like high sensitivity, broad linear range detection limit. So there are a variety of nanomaterial has been used for the sensor electrode modification. So here we especially in this lecture we are seeing about the metal sulfide composite for the electrode modifier for the highly electrocatalytic and electrochemical sensor performance. So in this direction, first we are looking about the copper sulfide. It has a peculiar property because it has a high conductivity, tunable conducting based on the composition formation in the copper sulfide. So it has been highly interested in various applications and particularly it has a good electrochemical activity in electrocatalyst and electrochemical sensor applications. So this the then this copper sulfate compound has broadly used for the various applications because of the special properties like unique chemical and physical property, making them wide range of application. For example, this copper sulfide we can use for the optoelectronic device, supercapacitor, battery electrode, and photoelectrochemistry, photovoltaic sensor, and also can be used for the electrochemical sensor. Here, really, we are using the how we can synthesize this copper sulfide material through cost-effective and simple approach, and what are the synthesis parameter influence on the formation of this copper sulfide. We will see then the following slides. So in generally, any nanomaterial we can synthesis or we can use the different synthesis approach. In particular, this copper sulfide material we can synthesis by either hydrothermal and solvothermal method. So the main difference between the hydrothermal and solvothermal method, this is the setup for the fabrication of hydrothermal and solvothermal. If we, in this reactor, if we use only water, which is called a hydrothermal, whereas in instead of water if we use some solvent like ethanol, methanol or DMF or mixed solvent like water ethanol mixer, like that if we use any solvent which is called a solvothermal metal. So what will happen when mixing the all the composition into the different well and kept into the stainless steel reactor, then we have to tight the whole setup and kept in the our required temperature. What will happen when applying the temperature above the boiling point of the solvent, it will create a high pressure. In this creating high pressure at high temperature, so the reaction mixer mixed together and form a our recovered product. This is the simple synthesis process for hydrothermal solvothermal. The main advantage of this hydrothermal solvothermal method, uh, we can get a highly reproducible synthesis. The morphology also we can attractive morphology we can obtain this synthesis method. Another is aerogel method. This is one of the popular method for preparing various nanomaterial and solution method. So this is a solution or solvothermal method, solution or salt gel method we can apply for the preparation of any nanomaterial. Here copper sulfate also we can utilize this in this process. And then thermal pyrolysis. Thermal pyrolysis, it is just keeping the precursor in a furnace, either box or tubular furnace, and it kept in a inert atmosphere. So both when applying high temperature, both the reactant can be oxidized and it form the vapor and it will mix with the corresponding metal to form a corresponding metal sulfide or phosphide. So this is also one of the popular method. Among this method, now we are especially looking the hydrothermal and solvothermal method for the fabrication of copper sulfide nanostructure material. For for the electrochemical sensor and electrochemical oxidation of small molecules. So this is the importance of shape control synthesis. So for example, there are different shape of nanomaterial playing important role to improve the catalytic performance. For example, if you prepare a copper sulfide particle or spherical morphology or sheet-like morphology or floor-like morphology or rod-like morphology, it is a significant role when changing the morphology of the copper sulfide property. The catalytic and performance of this copper sulfide product significantly changed based on the morphologies. So hence the self control synthesis is highly attractive in past couple of years because it is a unique morphology product. But the main things is most of the self control synthesis they are following using some surfactant or involve a complicated lengthy process to obtain a copper sulfide with a specific structure. So in this our investigation we are using simple synthesis process without using any surfactant or structure directing reagent or any polymeric material to form the specific nanostructure. So, template-free synthesis approach we are following to get the unique morphology of this copper sulfate. So, recent investigation have shown the size reduction of copper sulfate into nanoscale dimensional further cause a significant alteration in the physical and chemical property. This is the main criteria, main advantage when the any nanomaterial bring into the nanoscale, the physical and chemical property entirely different when compared to the bulk material. Because it has a large surface area, high surface to volume ratio, it will provide a special catalytic and sensing property due to the quantum sensing effect. This is a nanosize effect due to the quantum confined effect. Therefore, considerable attention recent year focused on the fabrication of nanostructure copper sulfate with different size, shape, and morphology. So, when bring into the nanoscale of this copper sulfate, the enhancement of the performance of any electrochemical application significantly can improve because of the quantum confined effect. So now we are synthesizing the copper sulfide coated polypyrrole. This is the simple schematic diagram how the material we have prepared. For example, this method we used a silica dioxide, silica particle as a template to preparation of hollow copper sulfide. After that, we have coated a thin layer of polypyrrole. Polypyrrole is one of the conducting polymer. So here I am explaining how we are performing to achieve the hollow copper sulfide. So it is a simple synthesis method. So initially we have taken silica oxide, silica oxide beer. It has been applied by Sargent process. It is simple, just mixing the simple polymerization of tetraorthosilicate in presence of alkaline medium. We will get a silica dioxide sphere. It is we have obtained the silica oxide in large quantity and as a uniform spherical morphology. In the following slide, I will show the how the morphology and interior characteristic we have observed for the SiO2. So first what will happen, we have prepared initially SiO2 sphere and then it is dispersed into the water. So it will uniformly disperse. Followed by we are adding the copper acetate into the solution. What will happen? The copper acetate completely dissolved in the water. Next steps we are adding the ammonia few drops. What will happen? So already in this solution silica oxide uniformly spread over the solution and then copper acetate also completely dissolved. It appear in a pale blue color. So when adding ammonia, the solution color completely changed into a dark blue color because it formed the copper ammonia complex. Because copper ion easily form with the complex in presence of ammonia. So when adding aqueous ammonia solution into the copper precursor plus SiO2 dispersed water solution to form a copper ammonia complex. What will happen? This copper ammonia complex uniformly deposited over the SiO2 sphere. in the solution. Each sphere containing overall over the SiO2 sphere, the copper ammonium complex covered by the each spheres. Further, we are adding in the sulfur powder into the solution and apply the high temperature like 180 degree in the hydrothermal approach. What will happen? So in presence of we are adding already in the ammonia solution into the solution. It is a basic solution, so the pH will be more than 8 or 9. So what will happen in this high alkaline condition? The sulfur can be easily react with copper to form a copper sulfur and then SiO2. So what will happen? This copper ammonia sample it is intermediate steps. At high temperature, when sulfur easily interact the copper ammonia complex and replace the ammonia and interact with the copper to form a copper sulfide over the this SiO2 sphere. So another beautiful things this when interacting with the sulfur with the copper, the ammonia complex release. So already the solution has a basic condition, alkaline condition. When releasing the more ammonia, still it pH of the solution increasing into more than 7 or 9. What will happen in the high alkaline condition? The SiO2 partially or almost 70 to 80% is slowly itching in the interior. So what will happen? The excess ammonia itching the SiO2 because silica dioxide is can soluble in the high alkaline condition like ammonia or NaOH, and also it can be soluble in high acidic condition like hydrogen fluoride. It is highly soluble. So in this case, high alkaline condition as well as at high temperature, easily the interior part of the SiO2 slowly dissolve. So what will happen here? The copper sulfide coated with over the SiO2 hollow structure has been obtained. Followed by this product has been collected by repeated washing and centrifugation. We will get a black color powder. Followed by this powder has been dispersed into the mild acidic solution and not mild acidic, in a neutral solution, and then added a recovered amount of pyrrole monomer. Pyrrole here for preparation of polypyrrole is a one-atom conducting polymer. The main advantage of this conducting polymer compared to other polymer, it is a high conductivity, and also the main advantage of this polypyrrole we can synthesis by in both condition, either neutral or acidic condition also we can synthesis the polypyrrole. Whereas in the aniline we can mostly use acidic condition for the synthesis of polyaniline. Whereas pyrrole we can use both acidic and neutral. Hence we disperse this copper sulfide hollow structure over the SiO2 into the water, and then we have added a drop of pyrrole, then added the oxidizing reagent. What will happen? We have added the ferric chloride or ammonium peroxide disulfide used as a oxidation reaction. What will happen when adding the oxidation reaction? When the solution containing this hollow structure plus pyrrole monomer, the pyrrole monomer is oxidized by the and it form a dimer like that. It is form a thin layer of polypyrrole over the this SiO2 modified surface. Then here polypyrrole coated copper sulfate as SiO2 hollow structure has been observed. So this is the overall scheme for the preparation of polypyrrole coated copper sulfate SiO2. So here the way we are coating the copper sulfide over the PPY over the copper sulfide SiO2 hollow sphere, because polypyrrole is a good conducting characteristic. It is a amine functional group which act as a highly catalytic and absorb a large amount of analyte molecules in the electrochemical application. So this is the main advantage compared to alone copper sulfate. When mixing with the polypyrrole, the performance enhance. Part of the another beauty of the things, when long-term electrochemical application, the copper does not reach it. It acts as a protecting layer without leaching. So hence we can perform a long-term stability application or highly durable durability of the material can be used for the different applications. So this is the overall synthesis. Here we used only a SiO2 as a template to prepare the highly uniform copper sulfate SiO2 and then polypyrrole coated copper sulfate SiO2. So, what is the advantage here when compared to already existing synthesis? In general, hollow structure can be prepared by either template method. One is soft template and hard template. So here we are applying hard template method. In already reported hard template method, this is the common process to obtain a hollow structure. So what will happen here? In generally similar way we are using the hard template. Here they will use hard template, and then our formation cell layer deposited over the hollow template, and then the template remove to achieve the hollow structure. What will happen while template removing? Here they will generally use a highly acidic condition like hydrogen fluoride or a high alkaline condition. What will happen? So here when using a completely etching through acidic or alkaline condition, the interior art template completely dissolve. So here the main disadvantage when using a high acidic and high alkaline condition, what will happen? It collapse the formation of nanostructure. So here the yield also very low, but here we did not control the any reaction. We can large scale synthesis also possible. So here the first step they taken hard template and the cell formed by the some chemical or electrochemical method, followed by the template was removal by using a high extreme condition like using acid or alkaline condition to obtain a hollow structure. So when removing this interior cell by in the second step, so this is a single step. When mixing with everyone, we will get a final product. Whereas here first we have to take, then the cell we have to form. After that we have collect this precipitate, and then the third step we have to use the some etching reagent to remove the things. So here we will get a low yield, and also the obtained morphology sometimes easily affect the formed hollow structure or collapse the hollow structure. So compared to this conventional or routine method, our method is a unique and special advantage because we did not take any further step. All the reagent mixed in the water solution. We will after the hydrothermal synthesis, we will get a highly uniform hollow structure over the SiO2 sphere. This is the main advantage of the our synthesis. So here the main objective this copper sulfate preparation, the advantage facile and scalable strategy for the fabrication of copper sulfate on SiO2 porous hollow sphere by simple chemical route and thin layer of polypyrrole deposited over the porous hollow copper sulfate SiO2 to form a BPY copper sulfate at SiO2. So what is the main benefit? The obtained new composite nanohydride exhibit interesting catalytic property for methanol as well as glucose electrooxidation application. So experimental how we are achieving this hollow structure means this is the simply explained through the flow chart. Initially we taken a SiO2 template which was dispersed in a water. Simply we used double distilled water or milky water. The dispersion was achieved by the ultrasonication. Followed by we are adding the copper acetate as a copper precursor in the concentration of 0.7 millimolar. Then we are adding a ammonia. Normally we used 1 to 3 ml ammonia. So it will form a copper ammonia complex. After that we are adding a sulfur powder in the concentration range of 2.1 millimole. The ratio between the copper and sulfur is 1:3. Followed by the mixed reaction was closed tightly in the stainless steel reactor. Then we reached the 180 degree for 16 hours. After that the whole setup was allowed to cool into room temperature. Then we are opening the this hydrothermal reactor. We will get a precipitate. This was collected by continuous washing with sequential washing with water and ethanol to remove the unreactant and the byproduct. Finally, we will get a highly uniform copper sulfide hollow structure over the SiO2 sphere. This is a simple synthesis. Here we did not follow any second or third steps, and also here we did not use any external acidic highly toxic chemical to remove the template. It is naturally removed into the autoclave steps. For example, this is the obtained material. So, for example, see here, this is the aspirate SiO2 collider particle. We can see the highly uniform spherical morphology. So, this is a simple process to achieve a SiO2. Hence, this silica oxide, the silica collider particle are broadly used as a template to prepare the hollow structure of many nanomaterial. So here we are using this CO2 sphere as a template by novel approach to fabricate a copper sulfide hollow structures. So this is the after synthesis we achieved a copper sulfate at SiO2. See here, so we cannot see we can see the similar morphology similar to SiO2, but the main difference, it is some dark color spherical, whereas here it is some bright color spherical particle compared to here. Why? Because the SiO2 is a completely insulating property. It has a poor conductivity, whereas after coating copper sulfate, the conductivity of the material further increasing. So this is the further PPY coated copper sulfate SiO2 sphere. Here, that diameter of the sphere here around 230 nanometer, here increasing 20 nanometer, further here increasing 20 to 30 nanometer. It is really indicate the thin coating of the copper sulfate as well as PPY has been occurred. So further confirm the crystal structure of the property by the XRD technique. This is the XRD spectroscopy of the copper sulfate at SiO2. This is the polypyrrole coated copper sulfide SiO2 hollow sphere. So the obtained peak are perfectly matched with the covalent crystal structure of our standard JCPDS file. Similarly, the after polypyrrole coating, the XRD the peak pattern does not affect, which means after the coating of polypyrrole, the formed crystal structure does not affect. It retain the both the morphology and the crystal structure after the coating of polypyrrole. It may be noted here the small broad peak has been observed in the range of around 20 to 23 in the to theta valley. It is due to the deposition of porous polymeric material. Further, the interior morphology of the material we can observed by the HR-TEM image. This is the TEM image for the CUS SiO2. So this is the HR-TEM for the CUS SiO2. Here we can see the uniform morphology. See here, for pure SiO2, if we take some, it is completely dark color, similar to like this. Whereas here we can see the two sphere when merging, we can see the boundary layer, which means it has a hollow characteristic property. Hence, and also it absorb and also it containing a small quantity of SiO2. So SiO2 we cannot remove completely because when forming the copper sulfide SiO2, it is form a completely mixing of copper sulfate over the SiO2. So it is difficult to remove all the SiO2 by the hydrothermal reaction. However, it is a highly hollow characteristic. Hence, when merging the two sphere, we can see the dark line. So alone it shows a very thin interior morphology showing the hollow characteristic. Followed by we are coating the polypyrrole over the copper sulfate SiO2. See here the surface characteristic of the spherical morphology retained when compared to copper SiO2. Whereas after coating the thin layer of polypyrrole, similar we can see the surface the surface coating or surface morphology here smoother, here more roughness we can see due to the deposition of polymer. It confirms the successful formation of copper sulfide hollow sphere, and also we have deposited thin layer of polypyrrole coating over the copper sulfide SiO2 hollow sphere. So this is the material we have achieved here by simple synthesis process, followed by it has been used for the so in order to optimize the reaction or to confirm the mechanism, see here this is the FESM EDX map for the aspirate copper sulfate SiO2. So this EDX spectrum clearly indicate the presence of copper and sulfur and silica and oxygen. So only we have observed this element. So this is a control so and also we have performed a controlled study without sulfur and without SiO2. What will happen? So when mixing with the SiO2 and the copper precursor sulfur powder, we are getting uniform spherical morphology. The same reaction if we are carried out without sulfur, only containing copper precursor and silica dioxide, what will happen? And also without silica oxide, only copper and sulfur source, what will happen? So we will see that in the following slide. So the EDX spectrum and also the image confirm the successful formation of copper sulfide coated SiO2. This is the XPS spectra for the both the copper sulfide SiO2 and PPY copper sulfide SiO2. So it clearly indicates the all the copper element has been observed, and also this high resolution spectra. Here we can confirm the formed copper has a copper 2 plus ion. So here compared to these two survey XPS survey spectrum, here we can clearly see the N1 spectrum. Whereas this the same pattern here we cannot see the any nitrogen peak because the nitrogen peak appear from the polypro. So it further confirm the successful deposition of the electroconductive or electroactive polypyrrole over the copper sulfide SiO2 sphere. So this is the high resolution XPS spectrum. We confirm the presence of copper oxidation state and presence of nitrogen and other elements. So this is the control experiment. How we are performing this control experiment? The similar under identical condition, we have used the copper synthesis. For example, without sulfur powder, we are using only the copper precursor, copper acetate and SiO2 sphere. What will happen? We are getting a different morphology, hierarchical porous morphology. Thus, this is the XRD spectra of this obtained product. So it is clearly indicate the formation of copper silicate. So without S powder, without sulfur powder, if we use the same reaction, we will get a copper silicate. The XRD also it is identical with the copper silicate JCPDS. So similarly, without SiO2, if we use only copper and sulfur, what will happen? It is form some lumps like a copper sulfate structure. This is a strong, this is the XRD spectra. We can have a strong crystalline peak. So without using a silica dioxide, we will observe a irregular morphology of copper sulfate product. So from this reaction, from this control experiment, we can conclude that to the formation of copper sulfate, uniform copper sulfate hollow sphere and polypyrrole coated hollow sphere is due to the presence of silica oxide and presence of sulfur powder in the water medium. Suppose if we are missing either silica dioxide or sulfur powder in this reaction, we cannot achieve this product. So from this control experiment, we can clearly conclude that SiO2 as well as sulfur powder playing an important role to the successful formation of copper sulfate. So see here, so when using a only copper and sulfur powder, copper precursor monomer, so we are following the under similar condition and similar concentration and similar temperature to confirm the our mechanism. So here from this control experiment we have clearly elucidated the mechanism to the formation of copper sulfide hollow structure. Here ammonia play an important role. So without using ammonia, the structure completely change. So because ammonia copper ammonia complex does not forming. So similarly, what will happen from this reaction? We concluded the mechanism initially the copper precursor mixed with water in presence of SiO2 silica dioxide hot template dispersed solution. Next we are adding ammonia solution. This copper ammonia complex uniformly spread over the as formed the silica sphere. Followed by when applying a temperature at 180 degree for long term, what will happen? The copper ammonia complex break and sulfur powder replace the ammonia to form a copper sulfide over the SiO2 sphere. The reaction prolonged long time, the high alkaline condition and high temperature and high pressure that interior SiO2 silica dioxide slowly dissociate and to form a highly porous and hollow copper sulfide coated SiO2 sphere. Hence, from this control experiment, we can elucidate the clear mechanism in order to bring the uniform copper sulfide coated hollow structure by using the copper acetate as a precursor and sulfur powder in presence of silica oxide and ammonia. So if we mix the, or if you mix the any reagent, the final product we cannot achieve. So next in the following our lecture series, we will see the how this copper sulfide coated POET has been successfully utilized for the electrocatalytic application and electrochemical sensor application. Thank you.